Hello and welcome back to the Hyperthesis episode 78. My name is Pheely.
I'm Liam.
Well, as you have noticed, we have a very short intro today and a third of us is missing. So Patrick is enjoying the time of his life in Spain at the moment. So he won't be joining us for this episode. So we are left with a couple of theorists. So we're gonna talk about some little discussion slash rant-ish. Who knows? Well, I'm pretty tired until my mental battery is quite low, even though it's only middle of the week. I'm quite exhausted for some reason. But, it happens sometimes. All we have to do is just prop up and endure.
It's a very busy time of the academic year because it's the end of the second semester. So, it's before summer break. All of the students have exams. There's a ton of marking to do. Like I've been doing a bunch of marking, preparing to help with exams, and I have my own deadlines to meet. This class I'm taking, I have my own projects that I have to finish that I got to worry about. So, you're probably going through similar stuff over there, I imagine. And also, we're missing Patrick, so we're already at a disadvantage in this recording. We're missing one third of our brains today.
Exactly. So basically, today we're gonna do a little chill-ish episode, because I got a little things I want to discuss with Liam. But to preface that, yesterday, do you know what a hopscotch is?
Oh yeah, so yeah. Well, I know like you draw it on chalk, and I it's funny you mentioned that because yesterday I was walking in front of a mall, and some kid drew like a hopscotch thing, and I did it because they told me to. They're like, do it, and I was like, okay, and I did some hopscotch yesterday.
Okay, because yesterday was a nice outside and graduate students at Queens here, we had a little event where we just get a bunch of sidewalk chalk and draw a hopscotch track from the in front of physics building from the main entrance to the another entrance beside it. So
Oh, okay.
it's quite long. So and it breaks down into the theory side and the experiment side, and in the middle, I think is this total solar eclipse. It's quite nice. I was part of the theory side, of course, and it was pretty fun to make it. I think it's end up with 90 boxes.
All
So
right,
it's
that's
quite a
not
long hopscotch.
it's long, but it's not too. I think by the end of it, I might be winded, but it could be longer, I guess, right?
It is, yeah, exactly. But the lengthwise is quite long. It's not bad. And I didn't really know the rules. I never really played growing up, so I was just doing some random walk.
Are there even rules? I thought you just like you hop across it with the numbers, right? Like isn't that the rule?
I thought, well, the way it was explained to me, it was like you're supposed to be on one leg and jump onto the next number, and you can switch leg when it's a double, whatever that means, like double
Oh
jump or
yeah, yeah.
something.
When there's like two numbers next to each other, you use both feet and then you swap legs. Okay, I knew about the using 2 feet, but I didn't know about the swapping leg thing.
Yeah, and there's like a double and triple jump. It's like it's its own thing, but um, there were two sides, experiment and theory, and we meet around, I don't remember which number, but yeah, it was
49.
fun. It was fun and make us think a lot about like, well, what should we put down? It's all like physics and science stuff, and since it's in front of physics building, hopefully it's not. Hopefully it doesn't rain today. We put quite some effort into it and write out equations. I put down the Dirac equation too. It's nice. Um, Someone wrote drew a Schrodinger's cat in a box. I was like, no, we're not gonna write Schrodinger's equation because now the box is moving at the near speed of light is relativistic. I'm gonna write down Dirac's equation instead. Schrödinger's equation a little boring, you know.
You
And
can you
yeah,
can have a relativistic Schrödinger equation. I think there's two ways you can think of it, although they're not too widely used. There's one where you write a Schrödinger equation, but then you put in the relativistic energy as like the eigenvalue. But the relativistic energy is a square root, right? Like E equals mc squared. Well, that's just like the low speed or the zero speed version of the relativistic energy. So you can have like E squared equals p squared c squared plus m squared c to the 4, I think it is. But then you have to take a square root of it. So now you have this differential equation with a big square root thing, and that's pretty nasty. And um, there's ways to get around it. You can like approximate it. I saw one paper where you say, what if we have small relativistic momentum, and you get something like an Airy function actually. But um, that's one way, but no one really likes that way, and I don't like it
well,
either.
I just want to write the slash operator. It's cool. It looks really cool.
Oh, for the Dirac equation, yeah, it does. Your
And
gamma
it's very
function.
succinct. It's real succinct. And I remember someone drew a sandworm from Dune. It just looks like a leash, but I just put the Schwarzschild solution of a wormhole on the bottom of it.
I don't know how
So-
you remember these things.
Well, we have the internet, but some of the things we know, like some of the things I know. I remember for the box 7, instead of put number 7, I just put the phi structure constant 1 over 1 3 and a big 7.
Yeah. Oh, I see. You guys like themed the boxes for physics things if you could, or you just wrote physics things in.
Yeah, at least for the theory part. For experiment part, they just draw a bunch of stuff like interferometer and whatnot.
They probably just drew a bunch of like springs and screws and capacitors and circuit diagrams. I don't know.
Oh, they in theory we want to like put a number that correlate to or like a theory that correlate to that number. I think that for the 19 to be like the 19th century. I think we put a tombstone. Is it Boltzmann tombstone? Is it? And yeah, with the entropy engraved on it.
I don't know what the Boltzmann tombstone is, but yeah. So
it is what you think it is. It's his grave.
Oh,
so if you look
like,
up his grave, he has like a sculpture of him, and on top of it's a S equal K log W.
Yes, because he used W for entropy or something. Or sorry,
Yeah,
not
W
entropy, for the microstates or whatever.
Yeah, number of microstates or multiplicities. And yeah, so that's what was cool. And I think I like it, make us think and see all these theorists try to think of theory that have those numbers in it is kind of fun, yeah, so it was quite enjoyable, but a lot of squatting down.
Yes, I would have done a lot of sitting on the ground. Yeah, but anyway, I just want to state that weird Schrödinger equation with the relativistic energy, it's not a very common thing. I've only seen it in one paper. And I mean, I haven't been looking for it, but then the other thing you can do is you can take you can do quantum field theory, and you can just have a Schrödinger equation with a quantum field. And again, that's hard. People don't do it as much. At least when you first learn quantum field theory, the way people do it is they like quantize Klein-Gordon equations, or they quantize like the Dirac equation, but or they quantize non-relativistic Schrödinger equations. But you can do it with the relativistic Schrödinger equation. And I think like the hardcore quantum field theory, that's like one way they do it. I don't remember the details, but I've read it somewhere in a QFT book. So
yeah,
there's a lot going on in physics, that there's so much that you could read and learn about that there's not enough time in like one person's life. Even if you didn't have any hobbies, even if you were just pure learning, you couldn't learn it all. There's too much. It's crazy.
Yeah, one thing that I got from that event, well, for me internally, is that just to realize the scope of physics. I think there's a little bit of less astronomy involved. I think we have a little bit of drawings from that. I'm glad I was able to put in some of the, condensed matter. There's some people do some photonics and optics stuff. And, to me, I like StatMech. Well, I can't believe I'm saying this, but StatMech is quite a niche field in terms of not many people like it.
I think it
But
depends where you're
yeah,
at.
yeah, I guess so. But maybe in my experience, maybe the environment in my university, in terms of like what people do, there's a lot of astroparticle and particle physics and high energy particle stuff. So StatMech is actually not a very popular course.
Hmm.
So, but it makes me realize a lot of what I don't know when people, come together from different fields, like going to a conference and going to a talk, right? And it's nice sometimes to just go into the field that you have no clue about, but they're doing like rigorous physics and the theories. And like Liam said, you realize that um, like a lifetime is very minute. Is so short to learn all these things. Maybe you need to be a super genius or something to learn all of this and be experts. And all the graduate school or PhDs come on about is about taking a thin slice of that or a thin slice of the knowledge and dig really deep into it and hopefully become an expert on very specific topic.
Yeah, and then there's every other branch of science outside of physics to worry about as well, right? Like there's too much to learn in a lifetime. Like even with instruments, I'd love to learn all these different instruments, but I don't. I'm the kind of person that I don't want to be mediocre. I shouldn't say mediocre. Like I'm kind of like an all or nothing type of guy. I don't want to be just average or okay at a bunch of instruments. I'd rather just be really good at like one or two, which maybe I'm limiting myself in the sense that I'm not getting to experience as many other things by doing this. But at the same time, like it's a hobby. I it's the same with physics. Like I'd love to do other types of science, but I don't know. It's easier for me the way I work to just like focus on one thing way more than a bunch of things.
I think when we were younger, it's easier to be jack of all trades. I remember seeing myself kind of like that when I was younger because I was doing pretty good in school and I was doing photography, video editing, and all these technology stuff. It was fun, right? And then as we grow up, we realize the depths of each field. I kind of gave up photography for quite some time now because I didn't find anything more interesting about it. It's kind of like set in stone in a sense of like, the thing that can only progress me forward is creativity because the technology itself or like the craft part to me is not that interesting anymore. Especially for digital photography, it's like, well, what else are you gonna do? You know. So I think a good photography now comes down to the story of the photos and what is really captured and the creativity that comes along with capturing the moment instead of the technical ability to, let's say, create change color or Photoshop. To me, that's not as meaningful anymore. And I know people who are great at it. I used to be pretty okay at decent at it. I'm not great at it. I guess if I really got into it, I probably can improve myself. But I just lost interest in photography. Maybe because physics kind of took over a big chunk of my life, and photography became what supplements my understanding of physics instead of just as a hobby. Right? I was doing it to make a little bit of a living for a little bit too. So that kind of took some joy out of it when you have to be like when you're an event photographer And first couple times is great. You got to go to these events, and but if some repetitive things what I did in during university is like, well, I've been to graduation, I think about 6 or 7 times, and you start recognizing the species all the same pattern. What you're gonna do is all the same, right? Even the people are different, the photo booths and what to capture. It's actually really systematic. You can have. I had a system in my head like this is where I need to be here at this time. It's nice. It's work. I made some money off it, right? It's help. It helped my studies, but it makes photography as a means instead of like just a hobby, right? It's like a tool I use to obtain financial resources. And imagine, if you're, a professional bagpiper, right, Liam? So maybe people would still love that. People, they're professional musicians that love that job. But if you pick up something that's just truly a hobby, and now it becomes your part of your job, maybe part time, I think it takes a little joy out of it. Maybe that's why I was so what's called numb to photography.
I yeah, I think it's a little. It depends on your personality, but yeah, I think bagpiping is typically like people go all in. There's so many people I know who it's like it's their job, it's their life, which is weird because people listening might think like, oh, well, it's like how hardcore can instrument competitions get? But there's people like who it's straight up like they work at a music store teaching that music and they compete in it and it's their hobby. And when they go to the cottage for the weekend, they all them and all their friends bring the instruments and they play around the fire. It's like it's a lifestyle, man. And I'm somewhere in the middle where like it's my hobby, but I play them like 30 minutes a day at least, and then 2 band practices a week, and that takes up the band practices alone take up like I don't know, like 4 hours on a Wednesday and like 5 or 7 hours on a Sunday, and then every week, every 8 out of the 12 or so weekends in the summer, I'm at like competitions. It's a lot for a hobby, and I can. You're right. Like if you do it too much, it starts to not be fun. So you have to take breaks, and like that's what I like during our undergrad, right? Like I didn't do music very much at all, and I got back into it in the end, like after our undergraduate.
Yeah, I'm thinking of going back to do some photography. I haven't turned on my camera for quite a long time, and it feels like a little bit of a waste because like you realize you have all these little skills somewhere that can be utilized. That's why I'm doing this podcast. Allow me to use the editing software that I know how to use, right? And I have, if not for this podcast, I would never get to use it. And it's a good thing to do. It's fun. Well, sometimes, but I like having discussion about it. And it, yeah. What else? So in term like going back to the physics and theory stuff, for a long time I was undecided on what field or what type of physics I want to go through, or want to make it my own. Not really my own, but my life, because it's such a commitment in a sense, right? Even though you see people change from, let's say, they do PhD in string theory, and now it's kind of nobody likes really want to develop more with string theory as often as you hear. So the people change to auto fields that more impactful. So that it happens quite a bit, but to me it's hard to choose because I feel like now I'm with StatMech, maybe because circumstances, right? But a lot of choices or things that come into us in life are a matter of circumstances. If you're given option to choose from anything, we might never choose at all. So it happens, and now I'm sticking with it. I kind of like it. So, but how about you?
Yeah, I know. I'm the same way. I remember our old professor, Joe Appaloo. I think I asked him one time, or someone asked him, or maybe he just told our class because we had him for a few classes. He was a mathematician. Um, and he did evolutionary game theory, which was there's this movie called Beautiful Minds about this schizophrenic mathematician, I believe. I've seen it like years and years and years ago, so I don't remember the details, but I forget the mathematician, super famous mathematician, revolutionized his field, but he had a lot of like problems in the movies about him like dealing with them and all that stuff. Anyway, nothing to do with Joe Apollo. I just wanted to say that that's the mathematics that Joe Apollo did. He studied evolutionary game theory, and well, he still studies it probably. But he basically told us that how did he get into this field? He's like, oh, I just kind of went with the flow. I went to school because I like math, and then someone offered me like a master's in some field, and I went and did it, and then I just did a PhD in the same field, and now I'm here, right? Like that's kind of how it works for a lot of PhD students, and same with us. Like we were working for our old prof Brandon doing density functional theory, and I was like, oh man, I love ultra cold like gases, which I still kind of do now, but it's kind of different. Like I was like, oh, I really like density functional theory. It seems like a really cool thing to get into. And then all of a sudden we couldn't work for Brandon anymore. So then I was like, oh, I guess I'm not doing density functional theory. So I went and did like relativistic, quantum mechanics with Marsland. And then
I mean, yeah.
Yeah, and then I went and worked for Duncan because Duncan, my current supervisor, he's like, oh, I have this project kind of related to what you did with Peter Marsland that I like you'd be good for, and here I am, just doing this stuff because the profs at our undergrad university, they did so much they only did so much research, and I just happened to get lumped in with one of them, and then now I'm just kind of in that field.
I mean, it's the same to me, right? I work with Peter Poo, and got to work in thermodynamic stuff, which is very enjoyable at the time too. And it kind of steered me towards this path that I never thought myself as a stat mech person. I gotta be clear because it's not exactly stats. Stats people would get mad at me. It's like, it's not real stats. Well, I would say it's stats enough. But I never saw myself doing this stuff because I don't know if when I was younger, I didn't even like stats. Yeah, I like algebra and arithmetic and, solving equations and such. Differential equations was fun. And StatMech don't really have that much of it, right? But now, very few people, I think, have that life experience or the journey of something is a calling to them. And maybe that happened to us earlier, where it's like, oh, we want to be scientists, we want to be physicists. Maybe the title of the episode would be "The Lost Hope and Dreams" or something, because a lot of things we hear online, or especially in on this type of public information, what's called regime, where people post stuff, you always see the very thin slice of what people want to show to the world, right? And a lot of successful, quote unquote, people, right? Successful people, is basically showing like, oh, this is my calling. This is what I'm set out to do. This is what the world is telling them this is the purpose of their life. But I don't think that is an average or like a typical human experience. That usually I think we are just what's called we got swayed by circumstances, by environment, right? The fact that we become scientists is not exactly some deity dictates us. That's like, here's the path your life you must take. But it's not exactly total freedom either. We, in a sense, did not totally choose this specific field. But in a way, we did a little bit, right? We have some agency in our decisions, but those decisions are swayed by our circumstances that make us be even interested, or it's like what's called availability bias, because we only see what's available to us. Maybe there are three choices, but we choose one of them.
Yeah, I think in our case we had like 6 choices, because during our undergrad at our at our university there were, I think, like 6-ish profs, maybe plus or minus 1 or 2 profs, each with their own field of research, and assuming they were all looking for students, which I don't know if they all were at the time, uh, that's like 6 different branches of physics we could choose from to research, and then by choosing that, you kinda just start you go jump in a river and the river just goes, and you're not that you're stuck with it, but it's harder to get out once you're in. Um, I would love to go and do experimental physics. Like, the more I get into theory, the more I'm like, "Man, I would love to, like, do experiments at this like, in tandem with theory," but it's hard to you can't really get into experimental physics once you're in theoretical physics, because if someone wants to hire you for, like, a master's or a PhD in experimental physics, um, they look for undergraduate lab work. So they look for the fact that you know how a lab kind of works. You know that, there's like safety things and there's like procedures and cleaning routines and stuff like that, which is pretty basic. But I don't know any of that stuff. I'm a theorist. I know like a tiny bit from our labs and classes that we had to take, but that's it. So it's possible to get into like a master's or PhD if you never did undergraduate experimental work, but it's harder. And then to get like a postdoc somewhere or to get like actually hired in like a lab, not just like an academic one, but like an industry lab, they want to see that you've like done stuff in a lab. So it's pretty difficult, I think. It happens, but it's harder.
Well, it's skill issue, right? Like
Yeah, yeah.
because we are specifically trained for specific skills, and certain things require different skills. Like a lot of experiments people, they don't want to do theory because they don't want to deal with these, you know, equations or theories or calculations and such, even though they do a bunch of calculations doing their lab work.
But in my like all the best physicists I've ever known, not that I'd say known, know of is a better word. A lot of them were all theorists and they like transitioned to partial experimentalists over their lifespan. Like, I'm not saying they did it after their PhD, but probably in like their like 30s to 40s, like they had enough theory under their belt that they kind of started to understand like how the experiments work, through papers and things like that. And those physicists are the ones I aspire to be like, the ones who are very good at both.
And I feel like now that we have been in this for a while, we start to see a bigger picture in terms of time scale to what the career as a scientist look like, right? So it's not just like, okay, we gotta do this for, I think when I was in like high school or undergraduate, I didn't have that clear of an idea of what's the career of a scientist look like. It's like, well, maybe you go to do research somewhere and like, well, what happened 20 years later? What happened 30 years later? And now I think I have better idea, maybe not totally clear because it depends on where you are, what exactly is your job. Are you going to be professor or more like a research scientist or in the private industry?
Yeah, well, that's the thing I always thought was weird. Like, I remember during our undergraduate, no one ever really like told us how it worked, right? You just kind of learned as you went. Like, I didn't know what research was. I didn't know how it worked. The only reason why I learned is because a prof came to me and he came to us in our second year and said like, "You guys want to do research?" And I was just you're young and you're like, "Oh, I want to do anything I can to get better." So you're like, "Yeah, sure." And then you get thrown into it. You don't really know what's going on, and you slowly learn through trial and error and profs telling you things. And it like I didn't know that how a master's and PhD worked or how it progressed and how you could typically you do postdocs or you go and work in industry. Like it'd be I think they're starting to do it more now, but they don't really explain these things to first year undergraduate students very often, I find. And even the undergraduate students that like I'm TAing and who work for my supervisor, like you tell them some of this stuff and they're like, "Oh, I had no idea." It's like, "Yeah, I didn't either."
Well, in the more typical world where if you work for like let's say a corporate, right? Usually they have a corporate ladder,
Mhm.
specific hierarchy or steps you can go up and it's really clear usually. Maybe I'm wrong, who knows, right? But for example, teachers contracts, or like the ladder is quite clear. I think that level from like A0 to A5 or something like that in terms of pay, and you add years on that. At least in Canada, it's like that, right? So it's kind of, you kind of see where you go. But then in terms of academia for university, you have like assistant professor, and then if you get tenure, you get the associate professor, and then you can hopefully in the far future get like a full professorship. And but it's not as clear either in terms of financial pay and stuff, like because it also depends on funding and other factors. And it's, I think, a little more difficult to imagine the path of a career. And I don't even know if it's necessary to imagine a path of a career. You just live one day at a time. Is that good? But I think it's good to plan. So that's why I ask people about hopes and dreams. What exactly you see your future?
Yeah, it's I didn't realize how long it was when I first went into it. That might have impacted my decision on what I did in the past. I mean, I don't think it would have, but in principle it could have.
Yeah, and also I start to notice, maybe this is a accidental experiment I noticed, because now that there's a few people I haven't seen for a long time, I start to notice the threshold at which their faces start to fade from my memory. It's not like I don't recognize them, but it's much harder to conjure up their facial features, basically, right? You kind of can remember what they look like, and now it takes much longer time to invoke their faces up. I think my new threshold is about 3 or 4 years. I think 3.5, 4 years when the memories start to fade. It's pretty interesting. I never really noticed that before, because like I usually have pretty okay memory, but it's not like I can't remember them. I can, and also other information too. I can, but it's just like it's got lost in this pile of information that I had. Maybe I need to create some kind of memory palace to put memories in different boxes in my mind. Now people do that as memory trick, right? Like, or like to memorize thing, and I do that for certain things, so I can remember like 299792458 for speed of light.
It's funny because yeah,
Right.
I remember there's a bunch of, I know, like, I don't know if I still do, but I knew the first like 20 or 25 digits of pi at one point in my life.
Oh, I still remember like 20 digits of pi. If I That's the
Yeah.
thing is, I memorize those in my language, so I have to translate.
Yes, the joys of going to a country that speaks a different language, I guess.
Yeah, because it's that memory is kind of reserved. Well, we are not memory expert here, but these are just our accounts of our experience. Because I used to do a lot of memorization tricks all the time when I was younger, because I like memorizing like equations, numbers, and um, math, basically. Even though people say it's not gonna be useful later on, man, nobody's gonna use this. You never use this. Like, well, I like it. Maybe I would use it in research. Maybe I go to the bank and can just do mental math on like averages or standard deviation.
I find the harder I try and memorize things, the worse I remember them. So I've just stopped trying, and now I remember a lot of stuff. It's kind of nice actually, and it's interesting. I watched this documentary. I don't play chess or anything, but I watched this documentary on like how chess masters are so great at what they do, and it just comes down, well, not just, but a huge majority of it comes down to like pattern recognition. So what they did is they'd organize the chessboard with some setup that has been played before in some game, because in chess the way it works is like the first few moves, the more moves you make, the more possibilities there are, and eventually you reach like what they call, I think it's like a new game, like something that in principle hasn't been played before, and from there it gets hard. But a chess person, someone who's good at chess, like a master, they could look at a board and in 5 seconds they could know like this is this setup, or no, the experiment was that they'd give them like 10 seconds to look at the board, and then they take it away and say, all right, put all the pieces down where they were from memory, right? And then they got a master to do that and someone who isn't good at chess, so like me, for example, to do it. And when it was a recognized pattern, the chess masters would get like 80-90% of the pieces in the right place, and person who wasn't good at chess would get like, I don't know, 10% or something. But if they just randomly had pieces on the board that weren't in any particular pattern, the chess master and the chess non-master would score roughly the same. So it's a lot of pattern recognition, and I find for like memorizing equations and music and stuff, it's the same thing. Like I don't remember, like for math, I don't actively try to remember a lot of equations anymore, but I just kind of do because I try and remember, like I realize that I focus on like big key features. I'm like, oh, this integral equation has this type of thing in it, and from there I can like write it down and kind of like, oh, maybe there's a 2 here, maybe there's like an x in this spot, and I can usually do pretty good with that.
My friend gave me accidental advice on how to remember a joke. It's like, well, man, sometimes a joke is so long, how you memorize it? It's like, well, just remember the punchline, and and the rest would come. Just know it's like just one line, and you remember the story. Just tell it. You just tell it in a different way. Like, wow, that helps a lot. It's like how I memorize a lot of formulas too. It's like, well, it has to have one half somewhere, right? Or like, okay, what am I memorizing? Oh yeah, it just it's energy, or it's kinetic energy. And then if the features come out, oh, it has the kinetic energy, or like what's the partition function? Oh, it has to be sum over or microstate of the Gaussian, not Gaussian, the exponential or whatnot, right? And the structures start to come. And your chess example actually reminds me of the it's a lot of reaching here, but it's like the arrow of time and entropy. Because what you describe is basically how the universe progress, in my opinion. It's like you start from
Okay.
small possibility, small number of possibilities, small number of microstates, and as the universe progress forward in time, quote unquote time, is you have more microstates that are possible. That's how entropy increases. Entropy is counting microstates, right? The number of microstates that are possible. So it's like chess. At first, there's not that many combinations you can have, and at some point it grows. Entropy grows, meaning there are more possible moves you could make. But since chess is on a finite number of elements and finite discretized space, entropy has a maximum, right? That's why there are a maximum combination of move that you can have, even though that number can be very high. That's why Go, like the Eastern kind of board game, is really difficult because there are many more possible microstates. That's why traditional algorithm that use computers to solve might be not able to basically beat humans who have intuition and understanding better on the patterns. However, when AIs come along, I don't know if you heard of AlphaGo, that beat the best Go player in the world, right? And it's crazy because like there's so many possible combinations, and so many ways to counter it. And now AIs just recognize those patterns much faster than humans. I'm not saying better, right? I'm saying faster because they can play a million games, computerized game. Humans, if you play one game, you might take 20 minutes, 10 minutes, right? Can you beat someone who play 5 million games in 30 days and recognize all the patterns possible? Maybe you will. Maybe there's certain things that the algorithm or the learning miss. But if you play enough, if your sample size is enough, you go through all possible patterns and know how to counter it. That's a very kind of, fascinating way that they train artificial intelligence these days. That's why I think one of the most important thing to about AI these days is a training data set. And hopefully we have a guest soon to talk about AIs and such.
Trying to
But yeah,
I'm trying to think, is there anyone I know who does lots of AI stuff? But I think you and your friends are the people for that. Maybe Patrick's friends too, but no one in my group
yeah,
uses AI. So
I will have to use a little bit of machine learning for my project, which I'm not looking forward to. I feel like I don't like using a black box, but it's all right.
gets the
So
job done.
yeah, a lot of things, even chess can be related to physics, right? Because I remember because I had some code that does some of the analysis, statistical physics analysis of certain things, and apparently it's applicable to chess. Someone emailed me about it, about having the n number of boards on and n number of queens or something like that. It's like, well, that sounds absurd, but you probably can use entropy to kind of see what's going on in terms of instead of analyzing the combinatorics of the move.
These are the type of questions mathematicians like to tackle. They're the questions that, well, okay, I don't want to be mean to mathematicians, so I got to be careful what I say. Um, Mathematicians do a lot of great stuff that changes the world and advances society and all this jazz and whatnot. Just like regular non-mathematician scientists do. But a lot of mathematicians are quite happy to just study like seemingly silly questions just because they're curious. And I guess chemists and biologists probably look at what I do and think the same thing. They're like, why the heck does he care about this stuff? It doesn't, it's not going to change the world. And maybe it won't, but a lot of science that has changed the world was not expected to change the world. It was just done because people were interested in it. So it's definitely, there's no shame in studying something because it's interesting. But yeah, like the type of questions, like if I have a chessboard with 8 queens and this configuration, like how many potential outcomes are there? Those are the type of questions like mathematicians, like it's like these, what are those, the towers of Pinoy or something like that? Have you, they're like, you have like the rings and hoops and it's like how many like how many moves can it take you to get all the hoops from one side to the other side? What's that called again? Tower.
Well, those puzzles that are fascinating, right? And a lot of mathematicians like those puzzles, and
It's
I always yeah,
the Tower of Hanoi, or probably pronounced differently. Google that.
like in
Hanoi.
Vietnam.
Maybe, probably. I don't know. It's
Oh yeah, yeah, yeah,
Tower of Hanoi.
yeah,
Okay,
yeah. It's like
okay.
a city in
Oh,
Vietnam.
okay. I didn't know that. Good to know. But anyway, like I took a discrete mathematics course during my undergrad, and we had a question on a test, and it's like if you have if you have Tower of Hanoi with 4 pieces, and there's 4 different like pegs, how many moves can it take you to start from one end to the other, assuming that you can only move the towers in this certain configuration? And you know, I look at that and I'm like, what's this garbage? Why would I even care about this? Like, this is such an oddly specific scenario to even ask that question. But they have uses. Like, these things have lots of uses in like computer science and combinatorics and things like that. So anyway, I kind of went on this rant and I forgot where I was going, but yeah, like the guy who emailed you or the woman who emailed you about like this has applications in chess, that might seem silly, but like it could be useful, honestly. Who knows?
Yeah, I always, I like to look at these theories or theorems, so like, this kind of feel as the luxury theories because it happens more during peaceful time, right? If let's say you're at war, you probably are like starving. You're probably not thinking about these theories. You're probably thinking about what would win you the day or the war, or get food on the table. And we are very fortunate to be able to basically do this type of research where it's seemingly useless, right? It's ostensibly useless, but it could not be either because it's not. It might be apparent that it's not very useful, but no, it is in terms of like knowledge and how humanity progress is not exactly clear which knowledge is useless. Because sometimes the very useless stuff is provides a lot of insights to create or to provoke like in our mind for useful theorems. And that's why I really like those silly theorems, or little bit of funny puzzles, and it really allows us to be more creative, to look at theories and information in a new light or perspective that I think is good for imagination. And I think imagination is one of the most important aspects of being a scientist.
I think one example might be I know that the James Webb Space Telescope, maybe it was the James Webb, maybe it's some other telescope, probably the James Webb, but they use like origami in it and stuff. Like they took like they when they send it into space, it has to like unfold a certain way, and they use like techniques in origami to do that, because it's like, how can you most efficiently fit this thing in a sheet such that it unfolds in a certain shape, with the least number of folds and stuff like that. And that's one of these weirdly specific kind of like math questions someone would answer. Or there's other ones where it's like, I forget who did this, I forget the name of the mathematician, but it's like, if I'm on an island and there's like if I'm on an island and there's a bridge going to another island, and then a bridge from that island going to this other island, and there's like, chains of islands with bridges, it's like, how many, if I want to start here and end here, like what's the least number of paths I can take, or things like that. They have applications in like neural networks and understanding the brain and understanding like connections on computers and all kinds of things. Or there's even one where it's like, we should have a whole episode on these. Maybe we should find a mathematician to come talk about them, because I don't know if we've had a mathematician, like an official mathematician, as a guest. And again, mathematicians do all kinds of different stuff, just like physicists and chemists and biologists do. So I guess I mean more of like a pure mathematician opposed to an applied one. But
Well,
there's
I
like
thought you were talking about like the A star algorithm, like the Dijkstra. Before we have Dijkstra search algorithm,
mhm.
A star was a lot of I think Google used it too to search like the shortest route between 2 points in a map.
Mhm.
It's really cool. Yeah, but a lot of those invention or those theories come from really basic curiosity on maybe useless stuff. Where do you think origami come from? Just when you're young, you have a piece of paper, you're gonna fold it for fun, and you want to make funny shapes and silly shapes to show your friends, and you want to make paper airplanes, and your friend want to make a better paper airplane, so you put wings in different ways. People make it into swans and ducks and frogs, and it just grow from there, right? So this kind of fundamental or really silly ideas really extrapolate or like grows into complicated theory. It's like your symmetry groups. Where do you think that come from, right? People ask these questions. What is symmetry? Why do we turn a triangle, a regular triangle, you know, we can turn it multiple, how many ways can we turn it? And so it's still the same shape. It's this very fundamental question that when we try to answer them, is really difficult. It's like, oh, why do this material red? That's like, oh, well, what do you know quantum mechanics? Like what?
Yeah, it's kind of funny that you said, why is this material red? Because that's like, the type of question a child would ask. People are like, why is kids always ask these out of pocket questions, I find, right? Like, they're like, why is the sun like yellow? And it's like, that's kind of like, at first you might say, well, I don't know, it just is. But it's like this deep question that requires a lot of knowledge to actually answer. It's like, well, technically it's white because it's all these elements giving off, you know, light because of this quantum mechanical reason, and then when it comes through the atmosphere, it filters out some of the, like, so it becomes more yellow, and that's why the sky's blue. And so kids, I like kids asking these types of questions, because they're out of pocket questions. Like, when I walk, why does my shoe squeak? It's like, what? It's like, who would think of something, like, who would care about that, but it's always the kids I find that ask the best questions. And those are the
Well,
type of
yeah.
questions I try and think about to myself now as well.
Well, it's just like it's basically peak human curiosity when you're young, right? It's like
Yeah.
you were curious about everything, why things like that, and I wonder, when do people stop being curious and just like, all right, I'm gonna go just like put my head down, work, and just not really questioning anything. And I think there's an element of where life starting get into in the way, right? Because when we were young, a lot of things were done for us. We don't have to really worry much about like food for most people in the modern world, right? Like they're not really starving, at least not in North America. Um, and the idea of things kind of, well, you have to be responsible for, it's not really there, right? You just like, okay, they tell me to go to school or they me to stay home, so like what am I gonna do? I'm gonna look around, I'm gonna look at the sun, I'm gonna look at not look directly at the sun, but look at the grass and every blade of grass, how's that form. And I think it's very fundamental nature of human that really you know leads humanity into be more very scientific, or some would say spiritual, but I think there's a very um, not orthogonal, but they're quite distinct, that our experience can basically propel us into a different trajectories in life, right? Imagine, instead of when we are curious about a blade of grass, we're like, wow, because there's spirit in the blade of grass. Well, I mean, that could be one logical conclusion or deduction that come out of that, right? It's like maybe there's something living in the grass, and they're partly right? Because there's cells, the plants, and where you can look at it spiritually too, the spirits, and you know even some things in nature that are fearful or like free invoking, like maybe there's some apparitions, and a lot of ancient cultures or older culture traditions, they worship apparitions. Even in my countries back in the days before before structured religion came in, there were belief in ghosts and apparitions and these kind of natural phenomena that they could not explain. So it's like, well, maybe it's due to apparitions, and people basically, what's it called, make it much more and more complex, try to explain using that, like rituals, ceremonies, spirituality, and it turned out to not work very well. It's not very objective. It's the experience very subjective, and the fact that we have logic and science, it kind of help communicate, because I can show Liam an equation and he would understand, and the same way I understand it, hopefully, because is the logic is a language that facilitate objective understanding or objective communication. At least that's what I think. Because without logic, it's kind of hard to communicate, isn't it? Because the cause and effect is not, well, is if it's subjective, it's different for every person. How can you talk?
Yeah, well, that's the goal of it, right? Um, like when I took this math, I mean, you were probably in it, I don't know, but when I took this math course in my second year of undergrad on like discrete mathematics is what it was called. You had to learn, like, you might have skipped that one, but you yeah, you had to learn like how to speak math. And I'm not talking about like what a physicist would call math. I'm talking about like logic, like what a mathematician would call math. They have their own kind of language for it with symbols that mean certain things, and like contradictions, and like there's some kind of math. I don't want to call it a word because it's not a word, but there's some like train of thought that communicates assumptions and results and stuff like logically, so that there's no room to misinterpret them, I guess. And I don't remember how half of it works, but I remember some of it.
Well, there's a formal logic, all right? And I took little bit of it when I was taking philosophy. Um, I substitute your discrete math with a bunch of philosophy classes. So but
Honestly, that
it's
was
like, you know,
smart move.
yeah, like P then Q and then W, right? Like not P or whatnot, right? And there's like all these type of logical arguments that you learn, and if you break down a passage into basically not into logical form or logic format, is much more clear what they're trying to communicate. But that's how you kind of identify fallacies. If or if their passage or their argument makes sense or not. Sometimes it's nice to just write down like, you know, if it's rained, then it's gonna flood. Not rain, not flood. But then realize, well, maybe there's other things that causes the flood. So maybe that argument is not exactly sound, right? Because but you know, if it rains, it's gonna flood. Okay, sure. But if you see flood, then does it mean it rains? Whoa, right? That's why we have like if and only if. It's kind of they kind of have to identify that. I think spotting logical fallacies is it seems easy, but it's not as easy as you think when things are more layered and complicated, right? When you listen to the news or reading some articles, like oh well, and you have to think about if that's argument or what they say is sound.
Yeah, I guess it's the analogy is like there's necessary conditions, but they might not be sufficient. You know, I can own a car, but that's a necessary condition to drive a car, but it's not sufficient because you also need gas and a license and some other things. I guess you need a road too and wheels. So like anyway, I kind of I lost track of where we were going with this, but we're running out of time actually too. So I don't know if there's
Yeah,
anything we want to wrap up or because like we didn't really
yeah.
we just kind of ranted about whatever we felt like this episode, which is fine because we're missing Patrick. You know, it's not like a proper hyperthesis episode. We're just kind of talking about whatever we feel like, and we do this every now and then. But
Random walk.
yeah, it's a random walk exactly.
Yeah, it's a brownie and motion episode.
So I never even properly learned about that because this is so you love StatMac, but I hate StatMac. Not that I think it's wrong or anything. I just during our undergrad, we only received half a StatMac course, even though we were supposed to receive a full one, and that's a whole topic we could talk about if we wanted to, but let's not. And then during
Well,
so we received like half a StatMac course, and then when I went to grad school, I was supposed to take a graduate StatMac course, which I did, but then COVID hit during the middle of it, so I got freaking screwed out of another half a StatMac. So like my StatMac knowledge is considering I've taken 2 full courses on it. I think it's only like 3/4. I only retained or learned about 3/4 of the material I should have, and that's why I don't do StatMac.
well, in a sense, statistics is a newer math. Think about it. Algebra and arithmetic and geometry has been around for thousands of years, but statistics in its essence, like you know, let's say like the meaning of average, how it's useful, only came up or like it only be relevant not so long ago. Like people are trying to understand distribution and probabilities and such. It is new. They're not that old. So in a sense, it's something that's hard to grasp, right? Like what's the meaning of a standard deviation, right? Well, now that people know more about stats, it's easy to explain, but it's easier to explain the circle as a geometry, right? Than explaining, um, let's say a Gaussian distribution, which is like a very standard stuff. So yeah, so that's uh, what's what should I say? An obstacle for our brain to understand statistics in our mind, because I think is we are not very well equipped to understand stats for a lot of people, and probably including me too. It takes a lot of time to basically evolve my mind to make sense of statistics compared to, let's say, geometry. Well, high dimensional geometry still escapes me. So, there's that too. But it's something that we don't think about too much, right? Growing up, you see a lot of algebra, arithmetic, geometry, but statistics is to me, it's kind of, you have to think about it. You have to go look for it rather than rather than it presenting itself. So that's that. I think we should wrap up. And
Yeah.
do you have any lasting comments?
No, I don't. I'm trying to think of something like meaningful to say and revolutionary, and I just drew a blank. So
Maybe. So I think I'll close with this. Literally, I'm just coming up on the spot here. We talked about basically part of it was hope and dreams and careers and theories and how the vast the world and the abstract world is in terms of theories and theoretical investigation of humans. And I think I'm gonna leave with this. Even though we are trying to dig deep and be an expert on something, I still feel like we are just on the shallow waters, in the very surface of things, where the more you dig deeper, I may not find the bottom. And there's people, including your former supervisor, that believe there's a bottom. But I don't think it's reachable by humans. But it doesn't mean we should stop trying, because, to be the meaning of life is much more than that. And we lost track sometimes on what we are doing. And I hope from listening to this episode, you gain something off this very random walk. We go to all different directions. And I hope we gain something from it, because it helps us rejuvenate our mind, get the gears rolling on something that's not our work and our personal life. That's why I like this kind of journal type of episodes, or journal club kind of type. So I'm going to leave you with that. They may or may not be Patrick coming into, proselytized our work. So good luck, everyone, and take care.
we'll see you next time. Thanks for listening.